All right, YouTube, welcome back. Here we go. All right, so what are we doing today? Newton's method for finding roots. All right. Now, what's nice about this is it's a very good application, a very interesting application, maybe not a well-known application, of derivatives and limits. Convergence tables. So, let's take a look at this. Kindly consider the following function.
What if I meanly consider it?
Meanly consider it? No, did you never watch Bill Nye the Science Guy? That's how he always started this. So, kindly consider the following. Bill Nye? Nobody knows Bill Nye no more.
It's my favorite ride in Disney.
Right? Okay. My favorite episode was the naked mole rats.
That's impossible.
No, okay, that's impossible. No, there's such a thing as a naked mole rat. I'm not making this up. All right. Anyway, we digress, YouTube. So, what if I wanted the roots of this thing? What if I wanted to know where it hits the x-axis? Set it equal to 0. Well, the y values are 0. Let's solve for x. So, what do? Solve for x. Add the 2. And square root. And you get two possible answers, a positive and a negative root, right? Well, Newton got really upset about these kinds of solutions and said, look, how can he didn't have a graphing calculator, 1789. He didn't have a scientific calculator. How do I get a decimal equivalent for that? What if I want to know what that is as a decimal? Yeah. Castile, right. But he didn't have a Castile.
Hey, well, then he should have made one.
He should have made one. So this is what he did. He said, okay, what kind of shape is this? Mother function, a parabola, and what's the x-intercepts are plus or minus right 2, but what's the y-intercept? If you plug in 0 for x, what's y? Negative 2. So we know what this looks like. It goes to negative 2 on the y-axis, and positive red 2 over there, and negative red 2 over there, but what is that? I don't know. What is that? Is that point something? 0 point something? Is that 1 point something? Is 2 point something? 3 point something? Do you know, by the way? 1.414 something, right? So he said, okay, I don't know what the heck that is, but apparently it's somewhere between 1 and 2. Okay? So what if you make a guess at 2 and draw a tangent line there? Notice what's true about the zeros of the tangent line, or the 0 of the tangent line. What's true about it? Here's the 0 I want. I don't know what it is. Here's the guess I made, x equals 2. But now the 0 of the tangent line is a better guess, right? It's closer to what I want. I guessed 2, but the 0 of the tangent line is between 2 and the right answer. It's getting closer, right? What if that's not good enough? Do it again. All right. So at this root, it's really easy to get the root of a tangent line, isn't it? Yeah. Okay. Draw a tangent line at that x value. And then look at the roots or the zeros of the tangent line there, and it's closer still to the one that I want, right?
He was a smart cookie.
He was a smart cookie.
But how do you know what number to choose?
You can choose almost any number. Eventually it'll converge to the right answer, unless it's a pathological case.
Right.
There are pathological cases. We'll talk about that. Pathological? They're a little crazy. A little cuckoo in the head. Yeah, some don't converge. Some can get chaotic and fractal results, and we're not talking about those. We're talking about nice smooth curves with a definite 0 that's right, easy to see, and it's a differentiable curve, right? Okay, so this is what I'm going to do. I have f of x is x squared minus 2. Now, how do I get the first tangent line, the green one? So I want the tangent line at x equals 2. You know how to do this. You need f prime is 2x. And you have to evaluate this stuff at, where did I guess? At 2, right? So what's f of 2? 2 squared minus 2 is 2. Okay, what's f prime at 2? 4. So y minus, who's y1? 2 equals m. Who's m? It's a number 4. And who's x1?
2.
Right, the 2 that we plugged in is the x1. The 2 that we got out is the y1, and the 4 is the m. All right, so what do I want to know about this tangent line, the green guy?
The slope.
Nope, I got that. That's 4. The 0, right. So, well, So how are you going to get the zeros of that? What if you make it an mx plus b form? What are you going to do? Distribute. So y minus 2 is 4x minus 8. Okay, then add. So y is 4x minus 6. And then set that equal to 0. 4x minus 6 equals 0. Well, what do? Add 6 and you get 4x is 6 and x is 3 halves or 1.5. So I don't know what the right answer is. And this is my guess. But apparently 1.5 is better. Now what do? It's a what? You make a new tangent line. The blue line is a tangent line through 1.5. So do it all over again. Okay. Let's see. So f of x is x squared minus 2. F prime is, 2x. F of 3 halves is what? Well, 3 halves squared minus 2. 3 halves squared is 9 fourths minus, well, how many fourths is 2? 8 fourths. So 9 fourths minus 8 fourths is 1 fourth. Okay. And what's f prime at 3 halves? Well, 2 times 3 halves is clearly 3. The 2's cancel, right? So y minus y1, who's y1 down?
Wait, what did you just do?
What did I do? The 2's cancel, get 3, right?
You got f prime is 2x.
Yeah,
And
2 times the 3 halves.
Finding the next derivative.
No, I'm trying to find the point of tangency. This is x1, this is y1, and I'm trying to find the slope there. This is m. That's all I'm doing. You okay?
Didn't you do that already in Rosen equation?
Yeah, but that was the green line. I'm doing the blue line. I did the tangent line at x equals 2. Now I'm doing the tangent line at x equals 3 halves. Not drawn to scale, obviously, but x is now 3 halves, so it's a different tangent line.
How do you know to do? Oh, because you're just so you're.
I'm trying to get more and more tangent lines. As I draw more and more tangent lines, the idea is that the roots of the tangent lines are going to get closer and closer and closer
So
and
you're
closer.
not finding the derivative again. You're just.
No, we're using the same derivative we had already. Right? I just rewrote this. Okay. Whoa. Stop it. Okay. All right. So y minus 1 fourth equals 3 times x minus 1.5 or 3 halves. Okay. I'm going to stay in fraction mode. Okay. Frac you. Now what? I want the zeros of this tangent line. How do you get it? Just like before. Nah, reference for wimps. What? Z equals 0. But what if we get into mx with speed form first? What? How? Distribute. So y minus a quarter is 3x minus 9 halves. Then add a quarter. So y is 3x minus 9 halves plus a quarter. Well, how do you add those two fractions? It's 1 quarter and negative 18 quarters. So 1 quarter minus 18 quarters is negative 17 quarters. And you want to set that equal to 0 and solve for x. So what do? Okay, so 3x is 17 fourths and x is 17 twelfths, whatever that is. Well, so this is getting really tedious really fast. I think we have to come up with some kind of a formula to do this for us. And then we want to put in as many tangent lines as we want. 1, 2, 3, 5, 10, 100, 1,000 tangent lines. Sounds like a program. Sounds like we're going to have to program our Castellanos. Yeah. So I'm not programming today. We're going to program tomorrow. I'm going to pick a problem that's easy to program, quadratic formula. So the math isn't the issue, it's the programming language we're learning tomorrow. And then the next, Thursday, we'll write a program for this. But first, we got to come up with a way to automate this stuff. Let's do that. Let's write this more in general. So let's say you have some curve, whatever it looks like. It can look like any smooth curve. I'm drawing the same thing I drew a minute ago, but any smooth curve will do. Okay? And let's say my first guess is x0. All right? What do I need to know to get the tangent line? I need the what? What's this? The y value. Let's call that y0. That'll be my first point, my first guess. My first guess is x, somewhere near the 0 that I want, but this is easy to guess. This, I don't know what it is, right? Okay. Now, I need to draw a tangent line there. How do I draw a tangent line there? Let's say it's at this point. That's terrible. Okay, so what do you write? Well, instead of y minus y1 equals m times x minus x1, you write y minus, well, how do you get y1 usually? F of x, 0. Okay. How do you get m usually? F prime at x0. And I'm doing x minus x0 just to be weird. All right. Now, that's the tangent line. Whatever f is, whatever x0 is, that's the tangent line. Whatever the curve is, I don't care. Right? This is more general.
Yeah.
All right. As long as the derivative exists. All right. Now, what did I want? I wanted to find the zeros of that tangent line. So what did we do? We said y equal to 0 and solve for x. Right? All right. So if I set y equal to 0, how do you find x1? x1, the next guess. Because x1, 0 is the 0 of that tangent line. So I know y is 0, but what's x1? How do you solve for x1? The same way we just did, right? Yes?
Should be.
Connor, you got mail. Ryan, you got mail. Okay. All right, so go ahead. How are you going to get x1 alone? Well, you know what? I want to get x1 alone. Can I get rid of the f prime?
Yeah.
Just divide. Okay. By the way, what is 0 minus f? It's a negative number. So I'm going to take negative f of x0 divided by f prime at x sub 0. And that's x1 minus x0. So how do you get x1? At x0. Okay. So you get that x1 is whatever your first guess was, right? Your next guess is whatever your first guess was, but fix it this way. Minus f of x0 divided by f prime at x0. All right. That's Newton's method right there. Now, this is what's called a recursive sequence. Remember this stuff? Recursion? What does recursion mean? That the next value is based on a previous value, right? So to get the next guess, you plug in the first guess, right? To get the second guess, you plug in the first guess. To get the third guess, you plug in the second guess. To get the fourth guess, you plug in the third guess, right? So in general, the next guess is the previous guess minus f there over f prime there. This is the rule that we're using. Now, that's in general. Now, what about our problem? Our problem was f of x was x squared minus 2, and f prime was 2x. Can I rewrite this general formula in terms of this particular problem? So x of n plus 1 is going to equal x of n minus what? What is f of x of n? What does that mean? Take x of n and plug it in. All right, so x of n squared minus 2 over, well, what's f prime of x of n then? 2x of n. Okay. So, if we do that with our initial guess, remember our initial guess was 2?
Yeah.
Right? So, if we say x sub 1 is x sub 0, which was 2, minus x sub 0, which is 2 squared minus 2, over 2 times x sub 0, which is 2, do we get the same result?
Yeah.
2 squared is 4, minus 2 is 2, over 4. 2 fourths is 1/2, from 2 is 1.5 or 3/2. Isn't that what we had?
Yes.
Okay. What's x sub 2?
Plug in 3 halves.
The next guess is the previous guess minus the previous guess squared minus 2 over previous guess times 2. All right, so the previous guess is
What
3
do you-
halves.
What do you do when you don't have an original guess?
You always have an original guess. It's up to you. You can pick anything you want. I usually pick something small, like 1, 2, something near the root. Okay. All right, minus 3 halves squared minus 2 over 3 times 3 halves. And do we get the same stuff? Let's see. 3 halves squared is 9/4. Minus 2 over 1 is 8 over 1. 8 over 4, that is. And we have a 3 halves here. And we have a 3 down there. No. Wait, I copied it wrong. There's a 2 here. So there's a 3 there. Okay. And aren't these the same calculations we did a minute ago?
But you didn't write the.
So, what? What?
You erased it.
I read. Oh. Okay. All right. So we get 1/4 over 3 is 1/12. So you got 3 halves minus 1/12. And how do you do that? Multiply top and bottom by 6. It's 18/12 minus 1/12 is 17/12. Is that what we got a minute ago? Okay. How do we automate this? Is there a way to make the calculator do this for us? Here we go. All right, Castiel. Now, I'm not programming this, but I'm coming up with a way of automating this so that I can't program this. All righty. All right, so the first thing I'm going to do, let's make a, wake up. Let's make a new document. No, what am I doing? What am I doing? I wanted to do a new document. Okay, let's make it a calculator document. Alrighty. Now, first thing I'm going to do is I'm going to define the function. Now, I want to do the same question we just did a second ago. Right? I want to do this, but I want the calculator to do it for me, so I can do x0, x1, x2, x3, x4, x5, x6 real fast. Okay. So, whoops, where'd it go?
So isn't that just storing an equation?
So I'm going to store the function, right? So on the home screen, how do you remember how you define a function on the home screen? What do you do? Menu, action, define, right? Or you could do this: x squared minus 2 is stored. Where's the store key? I can't see my blue stuff. Control var. Oh, you were saying it, right. I was expecting everyone to say menu. All right, so control var as, let's call it, I don't know, f of x. F of x. It's not doing parentheses, okay. All right, so if I want f of 2, it's not doing parentheses. F of 2, it knows what I mean, right? All right, and how do you get f prime at 2 if you wanted it? How do you do f prime at 2? How do you get the derivative at a point here? You could do menu, calculus, derivative at a point, right? Boring. How about the template menu? Do you see this thing here? Isn't there something here that says derivative? Derivative. And I don't know if that's... Okay, let's do this one. Now, you can use... Do you have your handheld with you? If you move your finger over this trackball, a mouse appears, and you can actually put the mouse here and click it, right? I can't do that with the keyboard, so I have to do this. Ding, 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 ding. We have a little musical interlude. This one. All right. So what do you think I got to type? Put the X there. Okay. What goes there? F of X. Let's do f of X to start. So f of X. And if I hit enter, I get the derivative of x squared minus 2 is 2x, right? Okay. What if I wanted it at a point? Right, how do you plug it in? With the with key. Where's the with key? Or such that key? Isn't it control equals the line?
Change the X.
Why is it doing that again?
Why is it doing that? Wait. If I hit enter at the right time. I did it.
You missed.
I didn't do
They're
it.
from Africa.
Oh, stupid computer. No Ebola jokes. Sorry, we're not doing that.
My mom really doesn't.
This it's not funny.
She doesn't have.
Wow, this is bad. Oh well. Remember, there's more than one way to skin a cat, fortunately. So I'm going to do it the other way. You know, have we done this with key x equals 2, right?
Do that? Why can't you
Because-
change the x
Because he
to
likes to
2?
see the
It doesn't work that way. That's how you plug it in with the vertical line thing. With key x equals 2. All right, so okay, so I'm gonna forget that. All right, so forget that. Go away.
What button were you hitting? It'll work on ours.
Yeah, it should. Yeah,
Which
Don't give up,
button
Mr.
did you use?
it was control equals and then go over to the vertical bar.
Don't give up.
All right, just do it. All right, so all right, I'm gonna have to give up. Sorry. Menu, calculus, derivative at a point. The variable is x, and the value of x is 2, and it is the first derivative.
Wait, so you just put the bar and you hit 2?
You wanted to say this: the bar x equals 2. So you type the bar x equals 2, or do menu, calculus, derivative at a point. It sets this up for you, and we want f of x here, right?
Yeah.
Okay. F of x.
But why can't you just plug in 2 for x? 'Cause
You
did
can. That's how you do
before.
it. That's how you do it.
You, like before, you just put f of 2. Why didn't you just do that?
Because f of 2 means plug 2 into f. I don't want to plug 2 into f. I want to plug 2 into f prime.
But you plug 2 into f and then take the derivative. That's why you.
No, because if you plug 2 into f, you get a constant, and the derivative is 0. That's not what you want. You got to do it the other way around. Right, okay. All right, so what's the rule then? Let's see. How am I going to write this? How about if we say, alrighty, let's call our original guess something other than x. It's getting confusing. How about we call it g? Okay. Now I want yeah, you want to do that? I don't know if I can do that. No, it's going to be confusing. I'm going to write this. Okay. I want to write this rule. Okay. I'm going to write g minus f of g over f prime at g. That's what I'm going to write. Okay. All right. So here we go. Where'd it go? There it is. Okay. So let's do. I'm going to say 2 store in g. All right, so my guess is g, right? So 2 is in g. And I want to do, let's see, I'm going to do g minus f of g. Let's see, I need a fraction here, right? How about a rational function? Control divide. F of g, let's see, f of g divided by control divide. Okay. Divided by the derivative thing, right? So let's do. Can I do it this way? I'm not gonna even try. So menu, calculus, derivative at a point, and yeah. Why does it always do that? Okay, and the value is at g. Okay, but I want f of x here. F of
What do you put in
x.
variable x value? Wait, is our variable g now?
Yeah, I made it g. Yeah.
And what's the value?
Okay, and what's the value? It's g. It's g. Here, I'm going to try and do the with key. All right, let's see if I can get away with the with key here. Okay, control equals. Why? Yeah. Good luck with that.
I thought you had great reflexes.
Just hit it right now. Hit it.
I did.
Now.
I did. I got it. It's there.
What do you do?
It's there. There it is. Okay. With. I'm going to do this. Enter. Where did it go? With x equals g. Okay, so with x equals g. So look, I plugged in g. I plugged in g here. I plugged in g here. I plugged in G here. Oh, do I need it there?
No.
I guess I don't need it. All right, go away. And enter. All right. So how do you do it again?
You click on it.
Well, let's see. But I got the same answer.
Got it stored.
You have to
Store it
change
again.
G.
Restore
G.
G. Oh, you're good at this. Okay, that's usually a major stumbling block for new programmers. So let's store second var store is store to G, so that every time it gets a value of G, it updates G. So if I run this again, it's on the new G, and I get another answer. Okay.
Stop it.
Stop it! Make it stop! All right. Now, is that a convergence table?
What?
I just hit it like 5 times. Is that a convergence table?
Because it doesn't give you decimal.
I want a decimal. So how do you make it do a decimal?
But how did it know to keep going
Control
up one
enter.
by one?
All right, let's start it over. All right, so start. To store as G, right?
Wait, no, but when you put in G, like, and then I hit enter, and then I hit enter again, it's going to the next number. How does it know to?
Because it's taking the value, the current value of G, making this calculation, spitting that out on the screen, but then storing the new G in here. So when you run this again, it's the new value of G that it's using.
And that's what it's supposed to do.
And that's what it's taking the last value of the last guess, plugging it back in to get the new guess. All right, so I want this, but I don't want to hit enter. I don't want to hit enter. I want to
Control enter.
do control enter. Okay, 1.5, 1.4. Now look at it, 1.41667, right? 1.41422. So this is, I guess, is this in fix 5? I guess this is in fix 5. You should write these down so you can see the convergence. All right, so let's write it down. 41667. Okay, let's do it here. No, stop it. What happened to my thing? All right, here's x, here's x sub n. X sub 0 was my first guess. X sub 1 was the 1.5, right? That's an n, that's an x sub n. Okay? All right, so let's get the values. Here we go. Can I play around with this a little bit? Make this a little bit smaller. That's not going to work because I want the big, that other big thing. Okay. Where am I going to put all of this? You know what? Can you see this? Is this okay? Can you see this?
Yeah,
All right, I'm going to get rid of this. I'm going to bring this over. I'm going to move this over here. And we're going to start over, all right? So 2 stored as G. And then do this thing with a control enter. Okay, there you go. Then do it again.
I mean, I did pretty good on the last couple.
All right, here we go. Okay, excuse me. All right, so now I've got, now remember on the AP they want answers if you get wacky decimals, good to 3 places. Now it's up to you to be consistent. You either round off to 3 places all the time or you truncate to 3 places all the time, okay? I'm going to truncate. I'm going to say 4166, okay? So the third guess is 0.4166, right? All right, do it again. Can I just do control enter
4167
directly?
if you're rounding.
There it is. I know, I'm not rounding, but it's up to you. Be consistent. Either round to 4 places or truncate to 4 places. All right, so now I've got my third guess, well, actually my fourth guess is 1.4142. I'm truncating. Okay. So do control enter, so it'll redo the whole thing all over again. And it's 41421.
So it's
And there it is. So there's your convergence. Four, 1, 4, 2. Well, actually, to 4 places we're done. To 5 places, it took that many iterations. All right, so 4 iterations after the first guess, you've got the answer. So what did we just figure out? The square root of 2 is approximately 1.414. How would you get the square root of 11?
Same thing, except you picked 12.
It's the same thing, except the function has to be x squared minus 11.
Yeah.
How do you get the cube root of 5?
X cubed minus 5.
X cubed minus 5. Find the zeros of x cubed minus 5. This is Newton's method for finding roots. Roots, not only roots where it hits the x-axis, but weird roots, radicals. He was trying to find really weird radicals. You can do this for any root. It doesn't have to be a radical, right? So what if I want the 5th root of 21? X to the 5th minus 21, right? So Newton's method, using derivatives of differentiable functions, nice smooth curves, will get you any root you want, in his case, any radical you want.
So we'll get the
Now, since we're doing it on the
Yeah,
calculator, right?
Last fraction.
Shouldn't we just have entered it originally on the calculator?
Enter what?
Like, radical.
Well, yeah, I know, but say you didn't have that.
Yeah.
No, you could do this by hand. He did this by hand.
Yeah,
I'm
but
just making it faster, that's all. Yeah. Okay. All right, so that's good for today, guys. So practice that up. Tonight's homework, page 248. Notice it's not evens or odds or multiples of 5s. It's just 53, 54, 55, 56. Okay? Page 248, 53 to 56. All righty? All right, so have a nice day, you two. Bye-bye.